Okay, so in this we're trying to solve an inequality with absolute values. So there's a general way you want to handle this, and the more traditional way that you usually deal with absolute values with inequalities is when you have a less than. Like for example, if you have the absolute value of x minus 2 is less than 5 or something like that, it would end up becoming x minus 2 is less than 5, and then you would put the inequality over here also and put negative 5. But what you need to focus on, because we don't have that type of inequality, it's a little bit different. So what you can think of it as is instead x minus 2 is less than 5, which gives us that part right there. But then we also have this part right here, which is essentially saying x minus 2 is greater than, notice that the inequality is opened up towards the x minus 2, right? It's opened up towards the x minus 2, negative 5. So what you want to think of and when you're approaching this inequality is, okay, we have x minus 9 is greater than 6. So I'm essentially just rewriting similar to what we have here, but without the inequality. Notice that without the inequality and nothing else changes, it really doesn't change at all. So notice that we have x minus 9 in absolute values is greater than 6. Just remove the absolute values and you still have greater than 6. But we also have another form, which is this one right here. And notice the difference here. Notice it's still x minus 2 in the example I had here. So I would actually have a second form as x minus 9, but then I would switch the inequality around. Instead of greater than in this case, it would be less than, and then we would have the opposite. Instead of 6, we would have negative 6. So that's all you're dealing with here. It's a little different. You can't write it in really the same exact way that we would tackle an inequality when we have less than. When you have greater than, it's a little different. Okay, so here are the two forms. Let's go ahead and solve each. That we've tackled the hard part, is separating it. Now we need to tackle uh, solving each individual inequality, which shouldn't be too bad. So we're going to add 9 to both sides. And actually the same here. Add 9 to both sides. We'll cancel out that and cancel out that. And what do we end up getting? X is greater than 15 and x is less than 3. Okay, so that gives us our um, our solution, but we want to give the answer as an interval, put it in interval notation. Okay, so if you might want to think of a number line. You can draw a number line, and notice we're at 3 and 15. But what is going on at 3 and 15? Well, it doesn't include 3, doesn't include 15. But which way is it shaded? Less than 3, so it's shaded to the left, and also greater than 15, above 15. Okay, that is what our interval notation should look like. Sometimes it's easier to look at the graph, but now let's write it in interval notation. So notice it's going from negative infinity up to 3, not including 3. Two separate intervals, we have to combine them with a union, and then it goes from 15, not including 15, up to infinity. It goes up forever. And that's how we would write it in interval notation. So we would write it as negative infinity to 3 union 15 to infinity. All right, let me know if you have any questions about anything I discussed here or anything else to help prepare you for your midterm exam. Remember, all these chapter review problems in My Open Math, We're in chapter 2 right now, but all chapters 1 through 4 is helping prepare you to take the midterm exam that covers those first 4 chapters. So please do reach out if you have any questions. I am more than happy to help.